Hi, I'm Swarupa Sail, course instructor for fluid mechanics. In this presentation, we will go through laminar flow for parallel plates. Let there be two parallel plates which are separated by B. This is what is the velocity profile. At the point of contact, there will be some resistance offered by the material of the plate onto the flow. So velocity at point of contact at both the plates is equal to 0. But as we move away from the plates, velocity goes on increasing. So velocity at the center is the maximum velocity and it is denoted by u max. And velocity at any distance y is denoted by u. Since velocity goes on changing throughout the width, that is b of the plate, average velocity or mean velocity is considered, that is uav, which is equal to 2/3 of u max. And this is what is the shear stress distribution diagram. So we can find that there is the maximum shear stress which is seen at the point of contact, and shear stress at the plate is denoted by tau naught. Since u average, that is the average velocity or mean velocity, is equal to 2/3 of u max, maximum velocity can be calculated using equation 3/2 into u average. And velocity at any distance y from the plate can be found out using formula 1 divided by 2 mu into minus dou p by dou x into by minus y square, where dou p by dou x is the change in pressure with respect to x, and minus dou p by dou x is found out using formula 12 mu u average divided by b square. And head loss due to friction HF can be found out using formula 12 mu u average divided by rho g b square into L, where rho is the density of the liquid and g is acceleration due to gravity and mu is the dynamic viscosity. L is the length of the plate. Discharge per unit width Q is equal to B into 1 into U average. And shear stress at the plate tau naught can be found out using formula minus dou P by dou X into B by 2. The pressure difference between 2 points delta P is equal to 12 mu U average divided by B square into L. Velocity gradient at the plate is equal to du by dy, which is equal to tau naught divided by mu. Now we'll solve a problem. Oil of specific gravity 0.92 and dynamic viscosity 1.05 poise flows between two fixed parallel plates 12 mm apart. If the mean velocity is 1.4 meter per second, calculate maximum velocity. Second is velocity and shear stress at a distance of 2 mm from one of the plates, and loss of head over a distance of 25 meter. For laminar flow between parallel plates, we have U average equal to 1.4 meter per second. So maximum velocity is U max, which is equal to 3/2 into U average. So 3/2 into 1.4 will give us 2.1 meter per second. Next is to find velocity at 2 mm from one of the plates. So the formula is U equal to 1/2 mu into minus dou P by dou X into By minus Y square. Here we need to find out what is minus dou P by dou X. For U average, we have the formula B square divided by 12 mu into minus dou P by dou X. So minus dou P by dou X is equal to 12 mu U average divided by B square. Mu is 1.05 into 10 raised to minus 1 into 1.4, that is U average, divided by B is 12 mm, so it is 12 into 10 raised to minus 3 meter, the whole square. So now we get minus dou P by dou X as 12,250 Newton per square meter per meter. So substituting this value of minus dou P by dou X in the equation to find U, we get U as 1.167 meter per second. Next, we need to find out what is loss of head in 25 meter length. So HF equal to 12 mu U average divided by rho G B square into L. Mu is 0.105, U average is 1.4, rho is 0.92 into 1000. Here density is not given directly, instead specific gravity is given. So density of liquid will be specific gravity into density of water. So specific gravity is 0.92 into density of water is 1000, and G is 9.81, B is 12 mm, so it is 1.2 into 10 raised to minus 2, the whole square, into length is 25, with which we get HF equal to 33.933 meter. Now we'll solve one more problem. Two parallel plates kept at 100 mm apart have laminar flow of oil between them. The maximum velocity of flow is 1.5 meter per second. Find discharge per meter width. Second, shear stress at the plates. Third, pressure difference between 2 points 20 meter apart. Next is velocity gradient at the plates. And finally, velocity at 20 mm from the plate. Take viscosity of oil as 2.45 Pascal second. The given data are U max is equal to 1.5 meter per second. U AV is 2/3 of U max. So 2/3 of 1.5 will be 1 meter per second. Discharge per unit width Q equal to B into 1 into U average, which is equal to 0.1 meter per second per meter width. Shear stress at the plate tau naught equal to minus dou P by dou X into B by 2. We can find out the value of minus dou P by dou X using equation 12 mu U average divided by B square. Mu is viscosity, which is given as 2.45. U average is 1 and B is also given, that is 100 mm apart, so it is 0.1 meter, with which we get minus dou P by dou X as 2490 Newton per square meter per meter. So substitute here in this equation to find shear stress tau naught, which will be equal to 147 Newton per square meter. Next, the pressure difference between 2 points 20 meter apart is given by delta P equal to 12 mu U average divided by B square into L. Substituting values, we get delta P equal to 58,800 Newton per square meter. Velocity gradient at the plate is du by dy, which is equal to tau naught divided by mu. Tau naught is 147 divided by mu is 2.45, which is equal to 60 meter per second. Velocity at 20 mm from plates, that is u at y equal to 20 mm, can be found out using formula 1 by 2 mu into minus dou p by dou x into by minus y square. Here y is 20 mm. So finally the answer is 0.96 meter per second. This is the reference. Thank you.